cosine and the arc cosine of x. And then this one would be the arc cosine, that says arc cosine, of the cosine of y. And this would be the tangent of the arc tangent of x and the arc tangent of the tangent of y. So again, if you have the inverse operations, they're like both, they're going to cancel as long as they fit the restrictions, and you're just going to get whatever's inside, whether it's an x, a y, or a smiley face. That's what you're going to get. Okay. So let's take a look at example 15 and 16 here. So first of all, we notice that we've got a cosine of an arc cosine. Okay. So what do we know about cosine and arc cosine? Can you tell me in the chat, please? What did we just say happens when we have cosine and arc cosine? Welcome back, Coral. All right. So the cosine and the arc cosine, they end up canceling each other out. That's right. And we just get what's inside. So it'd be 0.8. Okay. So what would my answer to 16 be? Can you tell me the answer to 16? Remember, I want to hear from everybody. Make sure you're helping me out. Okay, so it's definitely pi because we know these cancel. So we want those, right? Easy peasy lemon squeezy. However, the next one's not as nice. Okay. Notice it's a cosine inverse or an arc cosine with a tangent. All right. So these are going to work a little bit differently. So I'm going to do what's inside the parentheses first, just like we always would. Okay. So tangent of pi over 4. So I'm going to go to my unit circle. I'm going to keep the arc cosine or the cosine inverse. I'm going to go to the tangent of pi over 4. Tangent is the sine divided by the cosine, right? So I'm just going to write that out. The sine would be square root of 2 over 2. The cosine would be square root of 2 over 2. Okay. But what it's really asking me to do next is it wants me to find the cosine inverse, meaning it wants the radian measure when this is true. So basically, it's asking me for the radian measure at tangent of pi over 4. Okay. Hold on. I'm thinking, no, it's not. Sorry. It's not asking me for that. I need to reduce that. It's 1. Now I need to go and look for anywhere where my x value is equal to 1. So now I'm going to go around my unit circle and try to find where my x value is equal to 1, and I'm going to write those radian measures down. So I notice it's happening here. And we're looking for the x. So that's -1, so I can't use that one. But I could use 2 pi, right? So I'm going to use 0 and 2 pi. I'm going to hopefully explain it better in the next one, because I didn't do a good job there. I'm going to try one more time with this next one, okay? All right. So I'm going to try to find the cosine of pi over 6. So I'm just writing arc sine down. Arc sine, okay? Then we need the cosine of pi over 6. Can you guys tell me which quadrant is pi over 6 in? I love the Roman numerals. Okay, so pi over 6 is in quadrant 1. Okay. I am supposed to be finding the cosine of it, so I'm going to use square root of 3 over 2. Okay. Now I'm going to try, now I have to reverse arc sine. So I need to now find any radian measure where I have a square root of 3 over 2. Can you guys tell me what quadrants is, what quadrants is sine valid in? What did we learn yesterday? If you need to, look up a page in your notes or 2 pages in your notes. Which 2 quadrants is sine valid in? Do we remember? Oh, here it comes. Okay, so 1 and 4. So that means I'm only allowed to look for my next answer in quadrant 1 and quadrant 4. Okay. Is sine the x value or the y value? We've exhausted that question to death, haven't we? Okay, so sine is the at y value. So I know that I only can look in quadrants 1 and 4, and I'm looking for positive square root of 3 over 2. I'm noticing it's right here. So my arc cosine, or my arc sine of the cosine of pi over 6 is pi over 3. Hello, Mario. Okay. I'm going to bring my little, let me bring this guy down here. Okay, let's try this a few more times. All right, so is cosine, because now the arc cosine's on the inside, right? So is cosine the x coordinate or the y coordinate? X or y? All right, good. Cosine is the x coordinate. Which quadrants is cosine valid in? So what are the only 2 quadrants I can use for cosine? Be careful. All right, good job. 1 and 2. So basically, I'm crossing these out. I'm going to go look for the x value of positive 1/2 in quadrants 1 and 2. Oh, I found it right here. So I'm going to plug in the radian measure pi over 6. So tangent of pi, sorry, pi over 3, I misspoke. All right, so now this is saying go to pi over 3 and find the tangent of it. All right, so pi over 3 is right here. What's tangent? What divided by what is tangent? All right, sine divided by cosine. So my sine is square root of 3 over 2. My cosine is 1. Oh, our favorite thing to do on a Friday, right? We got to cross some stuff out. Isn't that nice? So I get square root of 3 over 1, or just square root of 3. All right. One more here, and then we're going to switch gears just a little bit. One more on the unit circle. All right. Technically, what's in my denominator underneath here? Can you guys tell me that? What's underneath that? Good job. It's 1. 1. Perfect. Okay. So remember how we built this up the other day? You guys just told me that tangent is the sine divided by the cosine. And remember, we have a 2 underneath absolutely everything here. So really what I am finding is I have the negative square root of 3 over 2 divided by 1/2, right? I built it back up to the coordinates, the step that we would have done before we canceled the 2's, okay? To get to the what they have in the answer there. So which quadrants is arctangent valid in? Can you tell me that? Which quadrants is arctangent valid in? All right, nice. 1 and 4, perfect. Okay, so I am looking for so if I think about this in terms of sine and cosine, my x value has to be 1/2. My y value has to be negative square root of 3 over 2. Or my x value has to be negative 1/2, and my y value has to be square root of 3 over 2. So I'm kind of looking for those 2 possibilities. I may not have both of them. I might only have one of them. So let's see what happens. All right, so negative 1/2. Oh, look, I don't have a negative 1/2 anywhere, do I? So I can't even use this one. But I have to look, so positive 1/2, negative square root of 3 over 2. Look, I got lucky there. But instead of writing 5 pi over 3, what did we learn yesterday? What's the new angle measure we put there when we're dealing with the arcs or the inverses? Remember I told you to write it on your unit circle? What did we put there? Who remembers? It's coterminal angle. We can't use pi over 3. All right, I'm liking what I'm seeing so far. Okay, so it's got to be negative pi over 3, because remember, we're only allowed to go negative pi over 2, negative pi over 3, negative pi over 4, 0, or negative pi over 6, 0, right, for our arcs. All right, so this is the sine of negative pi over 3, which guess what, is still taking us back to this coordinate, and the sine would be the y value. So we would be looking for negative square root of 3 over 2. A little bit more thinking, a little bit more written work than yesterday. Yesterday there was like no written work, right? All right. The next one that we're going to work on, we're going to go back to kind of the triangles. We kind of keep going back and forth. So these ones are really nice because we found values that were on the unit circle. It's not always going to be that way. So sometimes they're just going to give us a nice fraction. So when you see the nice fraction, you can always use a right triangle. So I'm going to draw right triangles for whatever my fraction is here. So, and the angle measure really almost doesn't matter. So, because we're just going to use the triangle. So I'm going to draw a triangle. I'm going to put a reference angle in there. Okay. So we're back in SOHCAHTOA. Did we talk about SOHCAHTOA in this class? I don't think we did. Did you guys ever hear the SOHCAHTOA story? Did Mrs. Rondeau tell it? Do you guys know who it is? Okay. All right. I didn't do it this year because of all the stuff that's come out. I need to reformat the story. Okay. So I didn't want to offend anyone, so I did not do the story this year. So, but if you know SOHCAHTOA, and if some of you are sitting in my room right now, right? Do you see the love note sign? SOHCAHTOA, and it says loves. It should be in the front right corner of the room. Do you guys see it? All right. Okay, so it says SOHCAHTOA. And he's got a girlfriend this year. Cho Sha Cow. Okay. All right. So everybody who was in my classroom this week check out all the signs because there was nothing else to look at, right? Okay. So basically, and these line up. This is the cosecant, that's the secant, that's the cotangent. So when we're working in SOHCAHTOA world right now, not trig identity world. Okay. So in SOHCAHTOA world, what's tangent? What divided by what in SOHCAHTOA world? What do you guys think? There we go. Okay. Opposite over adjacent. So I drew my right triangle. I don't have to necessarily draw it this direction. I can draw it any direction. And then I'm going to be opposite 3 over adjacent 4. What's my hypotenuse? Who knows what the hypotenuse is? Put it in the chat. We should know this one without having to do Pythagorean theorem. If not, do the Pythagorean theorem. All right. It's a good old Pythagorean triple, 3, 4, 5, right? So what this is basically saying is, hey, find the cosine of that triangle. So find the cosine of the triangle for arctangent of 3 over 4. Okay. So I'm just going to look at I know cosine is the adjacent over the hypotenuse. So my adjacent is 4, my hypotenuse is 5. Your work is basically going to be draw the triangle, right? So you can see the relationships on the triangle. All right. Looking at the next one here, okay, it gives me a little bit of a directional thing. So I'm going to have to deal with that somehow. Okay. Looking at this one, in SOHCAHTOA world, what's the cosine? In SOHCAHTOA world, what's cosine? What divided by what? We're looking for cosine. All right, so we're going to do adjacent over hypotenuse. So my adjacent is 5, my hypotenuse is 13, but here's the catch. Adjacent has to be the negative one, right? Because the hypotenuse is never negative. What does that make my other leg? What's the other leg then? I've got one person. All right, I like the fact that we're trying to go negative. We're not right, but that's okay. All right, you got the right number. You just have the wrong sign. Let's talk about this part though, okay? In arc world, okay, remember that cosine is valid in quadrant 1 and quadrant 2. So those are my only two choices, okay? If I'm out -5 here, okay, wouldn't I have to be up in a positive direction in that quadrant? There's no way to go -5 the other way. So the only way I can be is up in the quadrant. So that's going to be a +12, not a -12. That was a little tiny mistake. It's okay. All right. So now it's saying, hey, find the cosecant of this triangle that we drew. So can you guys tell me in the chat? Give me the number answer. What's the cosecant of that triangle? What do you think? Your cosecant's right here. Give me the numbers for cosecant. All right, good job. So 13/12. All right. Guess what? That's it for today. It was a pretty nice week this week, right? Because I said we're not going to do these two. Sorry, I'm killing some more trees, but Matt said it was okay. So earlier this week. All right. And then so all